Welcome to today's Control Design webinar on machine health monitoring with web-enabled sensor gateways. Today's webcast is brought to you by Control Design and Temposonics. I'm Mike Bassador, Editor-in-Chief of Control Design, and I appreciate your joining us today. This webinar is sponsored by Temposonics, an Amphenol company. Formerly MTS Sensors, Temposonics provides sensing technologies, including sensors and transmitters permitting high precision and dynamic position and speed measurement in automation and safety-relevant systems. In April 2021, Temposonics became part of Amphenol, a manufacturer of interconnect products. Before I introduce our speaker today, there are a few housekeeping issues I'd like to review. On your screen, you should have several primary sections. The audio section allows you to adjust the volume of this presentation. Just hover over this section until you see the audio volume control and adjust the volume to your preference. In the largest section is where today's presentation slides will be displayed. You will also see a group chat section where you can chat live with fellow audience members. The Ask a Question box is where you can type a question for the presenter at any time during today's presentation. We'll get to your questions during a Q&A session following the main presentation. Finally, you should see icons for additional features. By hovering over each icon, information about it will be displayed. If you're having any technical problems, you can type in your question or concern in the Ask a Question box, and one of our technical engineers will be happy to assist you. This webinar is being archived, and we encourage you to direct coworkers to the recorded presentation. If you are, in fact, viewing the archived version of this presentation, you can post questions in the Q&A box that will be forwarded to the speaker as well. Smart linear position sensors provide a rich set of diagnostic data useful for machine health monitoring and minimizing downtime. A sensor gateway helps to aggregate data across multiple devices and provides instant access to critical machine functions. Gateways can provide and display detailed information for operators to improve machine performance, optimize maintenance cycles, and detect at an early stage to increase machine uptime. With more than 20 years of experience in the test and measurement industry, shared between MTS Systems and Vishay Precision Group, Daniel Dockery served as an applications engineer before transitioning into the role of product manager. In 2018, he joined Temposonics, where his responsibilities include developing and maintaining product plans and product family strategies, coordinating product changes and introducing new products with the global marketing group, and supporting sales channels via sales calls to key customers. He's responsible for generating product presentations for trade shows and conferences, as well as webinars like this. Welcome, Danielle, and thanks for presenting today.
Thank you, Mike. Thank you for the introduction. I'd like to thank you, Marcy, and the rest of your team for this platform and giving us an opportunity to talk today about machine health monitoring with web-enabled sensor gateways. Before I do that, I'd like to advance the slide, make sure I'm in control of this. And I am. And as I said, my name is Daniel Dockery, one of the product managers for Temposonics. And today we're going to, as I said, cover machine health monitoring with web-enabled sensor gateways. Before I do that, I'd like to actually give a preview of what we're going to cover. Today we're going to initially start talking about Temposonics in general, a little more about the company. We'll then transition over to Industry 4.0 and IIoT particular information, followed by information on how our sensors, our smart sensors behave, and then how these smart sensors are mated or used in conjunction with gateways, such as the one that we will discuss today. And lastly, what we'll do is we'll just look at one or two use cases where our smart sensors and gateways kind of work together to solve a problem. Okay. So again, just a little bit about what we do at Temposonics. We are manufacturers of sensors for both industrial, mobile, hydraulic, as well as process control industries. These images here really there to help you think about where you might have encountered products that we've touched at some point. If you have a home that's made of wood, we were probably there at the point where the trees were being harvested, or even in the sawmills where the lumber was being produced, and similar. Or if you're using plywood in your home as well, our sensors were probably there as well. Even in the automotive industry, whether you're talking about rolling steel or taking and forming that steel into particular body panels or parts, our sensors were probably used in that type of environment as well. And obviously, we've got drinking bottles shown here. So if you have any bottles, whether it be water or soda or anything that is in a plastic container, then our sensors were most likely used in this application as well, for the lids as well as the bottles themselves. So this is just a few places or a few applications where our sensors have been used. There are many, many more, but just wanted to give you a little bit of background on that. So from a historical point of view, Temposonics has been making sensors since the early 70s. In fact, our first sensor was the Temposonics 1, and that was in 1974. And that particular sensor looked a little different than the ones that we're currently offering. All of the electronics was outside of the sensor itself. So that was a different form factor altogether. But then we transitioned to Temposonics 2, where we still had the external electronics option, but you also had the option of having the electronics be embedded in the sensor itself. And then again, we migrated to Temposonics 3 after that in the 1990s. And those particular sensors were, I think, our first foray into actually having sensors where we could remove the electronics, from like the hydraulic cylinder, and still replace the electronics and have it up and running again. After that, we transitioned to our Gen 4, or what we call our 2004 offering of R-series sensors. And these were the first sensors that we produced that actually had some type of diagnostics with them, specifically LEDs that were on the sensors to help figure out various things that might be going on with the sensor itself. But our most recent offering is our R-Series 5, or we refer to as the Gen 5 sensors. And those were produced in 2018. And those sensors also had LEDs, but these were the first ones that we offered that actually had IoT or Industry 4.0 related data being transmitted from the sensor as well. So just a little bit of background or buzzwords, things that we should get familiar with while we're going through this webinar. There are a lot of different words out here, a lot of different phrases that kind of have similarity in terms of what they're trying to do. For example, we have IIoT, which stands for Industrial Internet of Things, which is actually a subset of IoT, which is the Internet of Things, which we all know of. That's Internet of Things is where you're linking things together in a more general sense, like maybe your home TV might be linked to your security system, which might be linked to some other hardware that you have in your home. That would be more of an Internet of Things type of connectivity. IoT was more in line with having a similar kind of communication, but happening on a larger scale in more like a manufacturing type environment or similar. So that's why we say that it is a subset of IoT, but it is uniquely different than IoT. Industry 4.0 refers to the fourth industrial revolution that we've had. So as you would know, starting with the first industrial revolution, that was just machines working to produce product. That was the first revolution out here. The second revolution was actually just mass production, being able to take machines and help build different items out of multiple machines working together to do that. Then you had the third industrial revolution, and that was actually specific to automation. And then lastly, where we are now with the fourth revolution, this is where we're now tying things together via the internet. So when you hear of Industry 4.0, just think about hardware being mated together with the internet as the underlying technology that's allowing that to happen. Industry 4.0 is actually a German directive to be able to make sure that machines are digitized in Germany. So this is just unique to Germany. And then the last one is smart manufacturing, and this has to do with the United States trying to do something very similar. It's an initiative to make sure that machines are able to talk to one another and solve problems. So you'll hear these terms or see these terms almost used interchangeably, but we wanted to make sure that we differentiated between each of them. Because at the end of the day, the ultimate goal of all of these different buzzwords that we've covered is that they want to make sure that we have the ability to improve manufacturing through the use of connected devices. And connected devices, i.e. anything that has the ability to talk to another device and provide information that is understood by another device. So this ultimately is the area that we're in right now. All of our goals are to try to make sure that we're providing sensors that can do this type of work to allow us to be able to provide that information so that manufacturers can use that information and make intelligent decisions about what they're going to do next in their environment. So before we talk about gateways, we need to talk about smart sensors because they are the gateway to the information that is needed to be able to create this conversation amongst smart devices. So if you think about the history of sensors, we started out with analog type devices. These devices generally have individual wires and cables, and they basically are not able to connect to one another. They're basically separate entities on your device. So they're somewhat difficult to troubleshoot as well, which is one of the reasons why we migrated away from those sensors in a lot of applications. When you deal with field bus devices, they are capable of connecting multiple field bus devices, but on a single cable. And that actually saves costs and allows data to be transferred to and from the sensor very easily. After field bus came Ethernet devices. And these devices provide somewhat real-time data in the manufacturing environment that they're used in. They increase an overall connection distance because of the capabilities of Ethernet in general, where you're able to connect up to about 300 feet from the source. And you also have the ability to have multiple nodes as well. Lastly, we have IoT devices, and these are very much an expansion on Ethernet devices, except they provide the Industry 4.0 type information that a lot of customers are looking for now. So with that, these IoT devices will help minimize the cost by reducing factory downtime. So where do we stand as sensor manufacturers, which we are, Temposonics is, and there are many others? Well, we stand on, in this diagram, we actually are referred to as edge devices. And that means that these devices are at the lowest tier of the industrial Internet of Things hierarchy that you see here. So sensors, PLCs, all of these ride in that edge layer down at the bottom. And for us to make sense of anything that's coming from that, we have to eventually migrate the data from our edge devices up to these higher levels You have the communication layer, which makes pretty much sense. You're just trying to have that processing going on between your sensor and whatever hardware is trying to communicate with that. You have edge computing, and this is where you analyze the data that is coming from these smart devices or edge sensors. And then you have the storage layer, where all the data is stored for future reference. And then there's the aggregation or data abstraction layer. And at that point, your data is actually converged into a more simplified format so that it can be understood at the higher levels. When you get to the top layer, levels like 6 and 7, now you're talking about analytics. The data is now being parsed and then people are trying to understand what that data really means and how to react to it. And obviously the highest level here is when you have people that are looking at that analytic data and making decisions about what to do with this information. So, as I said, the foundation obviously is the edge layer, which is where we lie as manufacturers of sensors. So, as manufacturers of sensors, what role do we play in this market where people are looking for this unique data from these smart sensors? Well, as manufacturers, we have to provide actionable information for rapid troubleshooting to minimize the downtime, to help people schedule maintenance, and also to prevent failures in the field. So one of the challenges is trying to figure out just what information we need to provide to an end user so that they can make these educated decisions about what to do when they receive that information. So we have to help them, or at least inquire from them, what type of information is it that they want from us? What can we provide that will offer them value in terms of, preventing downtime or failures or similar? And how can we best provide this information to the end user, right? So these are the big questions that come up. If you think about it, when you're talking about Industry 4.0, IoT, all of this is just a reference to the fact that people are trying to ascertain information, and in reality, they may or may not know what that information is, or if or when they might use it, but they still want as much information as you can provide. So as a manufacturer of sensors, we have to find unique ways to make sure that we're not only producing our product and maintaining the base function of our product, which is in this case, providing position data, but also making sure that we are in a place where we can supply additional information that our customers can take advantage of and use to help solve their problems. So it is a tricky proposition, because a lot of times when we speak to people about this, they have the assumption that we already know which of these parameters that we're supplying are best to use or best to monitor to just help them figure out when things might go bad. But the reality is, smart sensors are just providing metadata, and that metadata needs to be properly reviewed by the end user and utilized by that user in a way that it will actually help them be productive in their environment. So I threw this slide up here, specifically the image on that slide, because frankly, I think all of us at some point have encountered one or more of these in our vehicles when we are driving along. Maybe it's just one, maybe it's more than one. The way I look at this is that this is a common methodology for car manufacturers to try and provide metadata that can help us make intelligent decisions about our vehicle, not too different than what we try to do with our smart sensors. The question is, when you look at that, which one takes priority? which one do you act on first? Which ones might you combine to make a decision about whether your car can be serviced or needs to be serviced now, or if it can be delayed, that service. So I just like that picture. I think it's pretty telling, and it reminds me so much of what we're doing with Industry 4.0 metadata. We've got a lot of different pieces of information that we're providing, but who knows which one or which ones will best help solve problems on the customer side. So that's a pretty good example of machine health monitoring. And in this case, the machine is the car. You know, what is the health status of my machine? You may have a dashboard that's been created to try to indicate which of these parameters is most likely to be the root cause of an issue for your vehicle, for example. But this also plays into the predictive maintenance or predictive analytics that you might have as well. Is my machine about to have an issue I can prevent? If you see a tire indicator and it's showing low pressure, do you continue to drive in your car with low pressure, or do you pull over and add more air to the tire, if you will? You don't want to wait until the machine fails. That's obviously not the goal. But you want to also be able to identify any issues that might occur before failure. For example, you might have a temperature indicator, like in the upper right corner of that image, there's a symbol for a temperature measurement, or at least a temperature warning. So if you're driving in your car and you get a temperature warning, you may want to, pull over and prevent your car from overheating or something of that sort. But the goal, again, is to identify any kind of degrading signals that are out there, whether it be in the quality of how your ride is. For example, if your tire is flat, you're not going to have the most comfortable ride. Or if there's a temperature-related issue, as I said, in terms of an engine, that could be an issue. You also want to optimize maintenance schedules, right? How often should I actually pay attention to these bells and whistles that are going off on my machine? Knowing when to service your vehicle is very important. Knowing when to service your machine is very important. So if you've got some kind of analytics set up that's monitoring the low-lying fruit, the things that are easier to repair and fix or get back into service, then you probably want to start with those first and work your way up, right? So these are the primary use cases for what we're going to be talking about: machine health monitoring as well as predictive maintenance. Now, as I said, as a company, we are manufacturers of sensors, but we also have smart sensors that are able to not just provide basic position information, but it can provide Industry 4.0 related information as well. This list that you see here is just a few of the parameters that we are currently able to provide. We can provide operational statistics. So if you want to use our sensor, which uses a magnet to track position, and you want to know how far that magnet has traveled over time, or how long your sensor has been powered up, operating time, or just how many cycles the magnet has seen during its usage, this type of information could be valuable, maybe for a cylinder manufacturer or similar. You might want to track the temperature. And that's something that we do. We monitor the temperature, the upper and lower temperature, over the life of the sensor to make sure that it's not exceeding any of the specifications that we currently have for our smart sensor. We also have violations that we can track. For example, temperature, min and max, or the power that's actually supplied to the sensor. That power, if you have a power that drops below a certain amount, the sensor won't work. So you want to be able to know over time, am I having issues with loss of power to my sensor, or excessive power, if you will, too much power to the sensor. If you're in an environment where there's a lot of vibration or shock loads going on, you might want to be able to track things like the accelerometer information, such as X and Y axis, as well as Z axis shock loads. We have the ability to track that as well. We know what the position of the magnet is. As soon as a shock load or shock event happens, we know where that is. And we can also track any excursions that might occur. So with a sensor that's rated to 150G, for example, anything greater than that, we want to know if that's happened. So that type of information is stored with the sensor, along with all of these other parameters that I've listed above. These are always part of the sensor, and if the sensor comes back for evaluation, we can look at that and determine if any of these parameters have been exceeded, or just get a sense for how long the sensor has been in service. And if there are any errors that happen to occur, for example, if you have a sensor with two magnets, but one of them falls off or is broken or damaged or similar, there is usually some type of response from the sensor that magnet has an issue. We can also check the quality of the signal that we're reading from that particular magnet. And that actually can be very helpful, because you may have different things that can affect the quality of the signal. And knowing that signal is not optimal is something that would be ideal for a manufacturer or a supplier, in this case us, to know if you've got a sensor going through that situation. Or if there are any communication-related issues. If there's a loss of communication or intermittent communication, all of these will throw some type of system-related error that we can then look at and say, okay, we have something unique going on, and this sensor needs to be serviced. Right? So smart sensors in general provide continuous update to these types of parameters, and we do that over the life of the sensor. Now, how do we get this Industry 4.0 data? There are a couple of approaches to this. It depends on the protocol, for one. If it's an Ethernet type sensor, any Industry 4.0 information can be transmitted along with the position data, or as we would say, the messaging in the Ethernet protocol in this case, would provide position information as well as the Industry 4.0 related information at the same time. So that's a very valuable tool to have a sensor that not only is aware of what its primary objective is, which is high quality position measurements, but at the same time is continuously being monitored for any type of excursion that might happen based on some of the parameters we saw on the previous slide. Now, if you have a protocol that does not have the ability to transmit that same type of information along with the position data, then this is where your gateway option comes into play. So you can use a sensor gateway to basically acquire any of the Industry 4.0 data that is coming from the sensor directly, while sending the position information from the sensor over to your control. So we'll look at that in a second here. So this is our Ethernet solution. As we said, the Industry 4.0 data is part of the data stream on the Ethernet solution. So whether you're talking EtherCAT, Profinet, PowerLink, Ethernet IP, all of these have the ability to send both position and Industry 4.0 data from the sensor to either a PLC, which would then push that onto some kind of analytics tool, or depending on the analytics tool itself, some tools can directly connect to Ethernet sensor and acquire that information without the need of the PLC. So this is a very common way that you can envision using a smart sensor with or without a PLC solution to get to the analytics. This is an alternative to that. As we mentioned, that any sensors that have that Industry 4.0 data but is not being transmitted with the position data can be still acquired by using an OPC-UA gateway. So this sensor on the left here is it's representative of two different sensors that don't have the ability to transmit Industry 4.0 data directly with their position data. That's analog as well as SSI sensors. So you have to fork that information off. So ultimately, the position data goes up to the PLC, and any Industry 4.0 data goes directly from the sensor to the OPC-UA module. Now, there is a reduction in terms of speed at which this information is being transmitted. When it comes to the OPC-UA environment, you're talking about using COPL communication, that's communication over power lines, if you will, to transmit that information from the sensor to the OPC-UA server. So that updates at a rate of once per second. Okay. But once it gets to the OPC-UA server, it can then be distributed through directly through a local area connection or through an Ethernet switch to multiple entities that might be listening or looking for that type of information. So you can still get it to your analytics tool after coming through the OPC-UA gateway. Or you can also send this wirelessly if you want to. Now, in terms of the OPC-UA gateway, it is, let me speak about OPC-UA in general. Forget the gateway at this point. OPC-UA is actually the communication layer that is used to take that data that we get from our sensors, that Industry 4.0 data, and presenting that in a format that is acceptable to some listener, in this case, a client of some sort. So OPC-UA, which stands for Open Platform Communications Unified Architecture, was actually developed years ago. Some may know the name DCOM, or you might have heard the name OLE or OLE automation. All of those are referring to the same type of communication. It was created by Microsoft Windows, and it was used in a very similar sense that gateways are used now, except it was limited to Windows operating systems. So for that reason, the OPC-UA portion, the UA, actually refers to the fact that now with the OPC-UA organization, they've made this available to everybody, even those who don't have Windows operating systems. So if you develop on a Linux environment, you develop on something other than Windows, you can still access OPC-UA specific data. Okay. Again, that communication happens between the server, which is the gateway itself, and the clients, and that's anything that's out here listening, whether it be a laptop or similar, that's listening for that OPC-UA related data. The primary use of this would be in factories, obviously. Anyone that's trying to transmit large amounts of data and trying to link all of this metadata together to create some type of solution, or at least an idea for solving certain problems, this is the tool that they would probably use, OPC-UA. And as you can see, there are over 450 companies currently that are members of the OPC-UA Foundation. So it's not surprising that OPC-UA is starting to become more of the standard for doing this type of communication. There is another methodology out there, and in fact, I believe it was before OPC-UA. It was called MQTT. And it was developed in 1999 by Dr. Clark at IBM and one of his colleagues. But ultimately, it used the same logic, the same concept. You had servers and you had clients, and those two exchanged information from one another, between one another. But MQTT is more prevalent in IoT environments, things like lightweight networks or home networks or similar. So most people, as I said, in the industrial world have migrated to OPC UA in lieu of using MQTT. But we didn't want to leave that off because it is still a methodology for communicating with OPC UA or gateway type data. So. Now, every gateway has some level of protection. Obviously, with the type of data that can be moving between clients and gateways, you want to have some level of protection, right? So the gateways themselves, they are that protective layer. They provide the encrypted messages that are needed when they're transmitting data. Also, these messages get signed also as another layer of protection. And they even restrict the size of the message to make sure that there's not too much information being transmitted across that could potentially be hacked or interrogated. In terms of access, there's usually an authentication layer to this. With our gateway that we have a username and password right at the front end to gain access to that gateway. And most gateways will have that type at a minimum, username and password, or they'll provide some type of certificate that you have to have on your system to actually use the gateway data. And that data is then provided to you either in read only or write or both, read-write capabilities. And lastly, that data can be used for generating audit events or any kind of failure modes that you might want to track, any kind of audit trails that you want to be able to go back and look to see who accessed the gateway at what particular time. All of that information is there as part of the gateway security. And this is just the hierarchy of that gateway. There are 3 different layers to that. You have the user access level, which is what most of us interact with. That's where you have your username and password that are specified. You have your application layer, and this is where you have your certificates that are passed between the application itself and the end user instance of that application to make sure that there is security. And then lastly, you have your transport security layer. And that's used to sign and encrypt any messages that might be exchanged between the client and the server. So this is a picture of our gateway that we offer at Temposonics. And just kind of peruse a few of the features. First of all, this particular gateway has the ability to allow for access to Industry 4.0 data without the need of a controller, that is a PLC. You can get that information directly. It always remains in line, so you have continuous access to this Industry 4.0 data. And as far as the gateway itself, it has the ability to support up to 24 smart sensors. That is, sensors that have the ability to transmit Industry 4.0 related data. It's powered by a 24-volt power supply. Normally, this would be mounted in your cabinet somewhere, along with all your other hardware, using DIN rail. And lastly, it communicates between the sensors with COPL, which is what I mentioned before. That stands for communication over power lines. Okay, so the data that we're talking about, this Industry 4.0 data, is being exchanged or passed back and forth between the gateway and the smart sensors via COPL communication. So we have 2 different options for dealing with this OPC UA data. Industry 4.0 data. One is to use the OPCUA server directly and connect to one or more clients. Option two is you can use the web interface, and that's the interface that was provided by us to allow you to view and mainly read all of the Industry 4.0 data that is provided by the sensors. So you have two different types of modules that can connect to the gateway. Modules, by the way, are the items to the right of the larger box. Those modules can support from 2 up to 24 channels. And so the channels that we can connect to this, or the sensors, if you will, that we can connect to this would be either of the digital type, which that particular module allows us to connect up to 6 digital sensors. And if it's an analog type input, we allow up to 3 per module. And that's just because we do some active filtering on the analog channels to make sure the data is pretty clean. Okay. So this is a picture of the web GUI that we provide with our gateway. And it shows on the sensor status page, you may not be able to read this clearly, but it shows a multitude of Industry 4.0 parameters that we can interact with. So there's magnet found, magnet set, magnet position, temperature, voltage, operating time, odometer, just like the odometer in your car, and then magnet cycles. And we even have faults, if there are any kind of faults that are happening. So if a magnet is damaged, it'll show up as a fault in the active faults parameter. So we have these parameters that you can track. Again, these are read-only parameters as well, so just know that in this environment. If you're using OPCUA, you can use something like a dashboard to be able to track this data or group this data, depending on which parameters are most important to you as provided by the smart sensor. So in this case, you have a dashboard with odometer for, like I said, for tracking how long or how far it's traveled, I should say. You have cycle count for magnet reversals on our sensor. Then you have operating hours, how long has it been powered up since it shipped. And we have max shock as well. You can track that. Is the shock load exceeding some specification that you have for your product? If so, you can map that in the dashboard. So to confirm that the gateway functions as expected, I actually went out and found a few tools that you guys may want to take advantage of at some point as well if you're using a gateway. All of these are free tools that you can download. Different companies that I found work very well with our gateway. But in this case, I'm actually going to use Softing's data feed because the user interface is very simple. And you guys would find it very easy to use if you want to try to access the Industry 4.0 data over OPCUA. So this next slide should actually be of our gateway connected to multiple sensors. And you can see the LEDs that are blinking there. Those LEDs are basically signs of COPL communication taking place. As long as there's blinking at each of those LEDs, that means each channel is transmitting COPL related data between the sensor, which you can't see because there are multiple ones. It'd be hard to put them all in the picture, and the actual gateway, which is, as I said, the larger box on the left. And again, there's a blue connection on the gateway right in the middle. That's a local area connection that allows us to send that data out to a network or similar. And then that can be sent out to anyone who's connected to that network. And they can monitor all the OPCUA related parameters. All right, so I have another video I'd like to share. And this video has to do with the data feed that I mentioned. see if it starts here. Let's see. Should start in a second. Yeah, there it is. So this is the data feed OPC UA client that I'm using. And the first thing I did was create a session, which is why that box popped up on the right-hand side. And in that box, I need to tell it what is the OPC UA server that I'm trying to connect to. So that's referred to as an endpoint URL. And in this case, I'm actually typing in opc.tcp://192.168.50.50. That is the IP address of the gateway. The last part here, 4840, refers to OPC UA communication. That's the port. So I go down at the bottom and confirm that this port is okay, and it says yes by the green indicator. And that's all I need to do at this point. And all I have to do from there is to decide what OPC UA specific Industry 4.0 data I want to access. So going down to this folder called Objects, I can look at the list of sensors that are available. By the way, that folder structure is identical no matter which OPC UA tool you use. It's always a views folder, a types folder, and an objects folder. And you're usually interacting with your data in the objects folder that is there. So as I've expanded this, I've chosen module 2 and sensor number 6 or port 6. And I'm just dragging things that might be valuable to us. Since we're a sensor manufacturer, I'm pulling position up there first. And then I'm going to put magnet set, which is corresponding to the number of ordered magnets for that particular sensor. Magnet found, I'm going to put up there as well, which is how many magnets are physically on the sensor stroke. I'm including odometer, magnet cycles. Again, these are things that might be important to someone doing Industry 4.0 with our sensor. I'm also including the temperature, the current temperature, even though the min and max are there. I'm also including the current voltage. And I think that's, let me see, that may be all that I'm adding here at this point. Yeah. Now, so to demonstrate this, I just need to go to Data, the Data tab at the top. It says Data Access. And currently, it shows the same parameters I just added, and their values are shown up there. So you have position. There are 2 positions shown. The reason that you see 2 positions is because I have 2 magnets on the sensor, as you can see by the video that I created while I was at my desk. So the position values are reported from the head of the sensor, where the red area is. If I remove a magnet, you can see that the magnets found went from 2 to 1. You can also see that now that I put it back, there are 2 unique position values there. If I remove it, again, the magnet, you see that it reduces to 1 position, 1 magnet. And then when I put it back, you can see that there are 2 magnets. Now, I should have been holding this a little bit, make it easier. But as I start to reverse the magnet direction, you can see that magnet cycles are increasing. You can also see that the odometer value is increasing as well, which means we're just traveling along with this particular magnet back and forth. But these are just examples of how you can view Industry 4.0 data using an OPC UA client when you connect it to a gateway. I believe that is the last image I have here. So to rehash, we started with smart sensing. Okay, and with smart sensing, there's an increase in the number of sensor solutions available to provide rich data to manufacturers make sure that they can make intelligent decisions about their Industry 4.0 information. We also talked about smart sensors, Ethernet-based smart sensors, and OPC UA-enabled gateways. And these are the mechanisms for allowing us to be able to provide inline, ready-to-use Industry 4.0 data. And lastly, we talked about how you leverage these solutions so that we can make sure that we improve on the quality and reduce the machine downtime, as well as optimizing maintenance schedules for those who need them. So at this point, do we have any questions? I put a few things up there, some numbers that you might want to access. There are applications engineers to talk about these types of protocols and specifically gateway that we just discussed, as well as email-related info. So, any questions at this point?
All right. Thanks very much, Danielle. Fantastic presentation. It's now time to take questions from our attendees. So everyone, to submit a question, just type your question in the question field, and we'll get right to them. Our first question, pulling up here, how does the interface protocol of the motion controller impact the decision on the Industry 4.0 solution?
Right. So if you have, let's say, a Ethernet-based sensor, EtherCAD, Ethernet IP, Profinet, or similar, all of those already have the ability to supply or transmit this Industry 4.0 data directly to the PLC in this case. So if you're using one of those protocols, then you can go directly to your PLC without an issue. However, if you're talking about an analog type input or SSI for that matter, both of those have, neither of those have the ability to transmit that type of information directly. So you'd have to use a gateway to gain access to their Industry 4.0 specific data.
Gotcha. Next question. What are the most common applications where someone would use the Industry 4.0 data?
Well, there are a lot of different applications, but probably the one that I'm hearing more about now is cylinder manufacturers who are trying to, track the usage of the cylinder, any type of over travel and things like that that might occur on a cylinder. So I would think that these would be probably the first people that we would hear from if they were listening to this to try to see about utilizing the gateway solution.
All right. Just going through here to follow up. Looks like that might be. Here we do have a question here. Another one. Does Temposonic provide open APIs for others to integrate with your sensors and create value-added products such as cybersecurity products?
So we don't have any APIs at this point. I'm not sure if we're going to make it down that path with APIs, but one of the things that we are working on or considering is providing some sample code to allow people to start interacting with the gateway. For example, we've been creating Python examples that we're going to probably allow people to get with directly from us that might show you the implementation of maybe one or perhaps two parameters that would be important to you, and then allow you to kind of expand upon that example to create your own dashboard or similar. Yeah.
Ah, excellent. All right. Well, it looks like those were our questions. I would like to thank our speaker, Danielle Dockery, again. Thank you, Danielle. Great presentation.
Thank you for having me.
Absolutely. I'd also like to thank our sponsor, Temposonics, and all of you who joined us today. Within 24 hours, we will let you know when this webinar is available for on-demand viewing. And again, if you do have questions that you think of after, I see a few coming in now, but we'll go ahead and follow up with those rather than continuing to start and stop. We can set these for thought, unless you want to take one more. We do have time, Danielle. You want to take one more?
Sure.
Okay. This says, does IO-Link, or I guess this should say, is IO-Link in your pipeline?
I need an expansion on that question because we do offer IO-Link, but are they asking something different than do we have IO-Link, or are they?
Right. Yeah. Don't know. That's probably a good one for follow-up. So let's. I see Matt's reviewing that one right now anyway, so we can just save that one for follow-up as well. So again, thank you, Danielle.
Sorry, just to reply to that. In case they are not aware, we actually have IO-Link, but it is part of our what we call our E-Series product line, but is not part of the R-Series, which we've been talking about in this presentation currently.
Correct. Right.
But it is something that is under consideration.
Okay. Fantastic. And I'm sure you'll follow up directly with the individual who asked that question. And he or she did provide some follow-up. I apologize. I don't know whether that's what
Sure.
gender that name is. So anyway, thank you again, Danielle. Thank you, Temposonics. Within 24 hours, this webinar will be available on demand, so you can share it with colleagues or review it as well. A lot of great information in here that I'm sure a lot of people might want to refer back to as well. We also encourage you to visit controldesign.com to gain access to even more tools and resources aimed at helping you achieve success. Did you like this presentation? Go ahead and let us know your thoughts by answering our brief survey that should be on your screen right now, and will remain there when the webinar ends. Your candid answers are not only appreciated, but they do help us to craft future events as well. Thank you for your attendance, and have a great day. Thanks, Danielle.
Thank you.